May I now request Dr. Roy to come and share his experiences on the RE performance monitoring and optimization services. Over to you, because next chair of has come already. I would request you to keep it for the 15 minutes. Sorry for cutting it short. Thanks.
That's absolutely fine with me. Good afternoon, everyone. How many are you feeling cold? Me too. 4 days ago, I was in 5 degrees in London, and here I'm feeling cold. And in the previous session, it's not about that. The reason, because the architecture in the previous session, he mentioned about the tech city in Chennai and how they achieved by reducing AC load. If we turn the temperature down 2 or 3 degrees lower, will you feel comfortable? Yes. Will it reduce the temperature? Will it reduce the demand? Yes. Saving is an income. I think that's the concept. When I entered to my hotel room here, I reduced the temperature from 22 degrees to 25 degrees. I was comfortable. It's actually what we want and what we need. That's the choice we need to make. What we are after, running after, rather, what we want rather than what we need. I think what we need to focus on, what we really need. Otherwise, we're not giving the tomorrow for our next generation. Right. Coming back to the topic, I will be mainly focusing on solar and energy storage, though it is a built environment, but the tools and processes that I would be going through in next few minutes, it relates to utility scale system, solar and energy storage systems, but also that is equally applicable to built environment, whether it's on-site or off-site. And I'll start with another question. Do you know anyone who has got no generation loss of their solar system? Based on our experience into different market, answer is no. All system has got level of generation losses. And it's not country-specific problem, that's the global problem. Question is how we recognize it and how do we address it. So the problem really is lack of generation of the solar system, is generating lack of revenue as predicted, compared to as predicted. We have developed a tool called PV-APM, PV Asset Performance Management, so that's beyond traditional O&M, beyond traditional asset management. With about 500 megawatt of project we have applied in 6 countries, and on average, it has resulted into 8% generation, additional generation. So that has an impact of additional CO2 offset, but also commercial impact by producing additional generation. Going back to that AC point earlier, saving is an income. Operational efficiency improvement is an income. So what we are doing with this PV-APM is increasing an energy efficiency of an energy efficient system, which is solar system. We are a technical advisor with over 11 gigawatt of different services, whether design optimization or technical due diligence, owner's engineering, or PV-APM I mentioned. We heard in the previous session about AI and machine learning, buzzwords in my point of view. What is those? Simple mathematical formulas. How do you utilize it? Making things complicated, that is our nature. But if we wanted to call ourselves as an expert, our job should be to make it simple so that people can use it in a simplified version. I'll take one other example. When I started my PhD over 20 years ago, my supervisor said, make your presentation to someone who has got no understanding of solar technology. If you can do it, you make them understand, then you've done your PhD. I'll give you another example. There's one guy in Germany who did PhD. Do you know how many pages his PhD thesis was? Can you imagine? Any guess? 3 pages. Just 3 pages. It was as simple but as impactful. Thank you. So yes, making things simplified. I think that's the mission we should go. All the solar standards that are coming into market, being part of a BSI standard committee member, either I've written them or reviewed them or approved them. It's a very complex process. Very, very complex process. Needs to go through, because making it an international standard, it needs to, first of all, we lock ourselves in a room, and you develop something, it go out in the market to get the market review, not just national market, it's an international market. It has to go to all different countries and get it voted And then only when it's approved, then it will come into market. It's a complex process to go through. At Greenenco, we have developed a certain partnership with some private companies or public entities. For example, just to give you one example, with TS Redco, Telangana Renewable Energy Development Agency, and various other companies that we are working with. So what we do, we manage risk at different stages into two cluster operational assets and new build project. Two main pain points: generation loss and due to lack of data-driven decision-making process. How do we do with those data? And still, we talk about a lot of proactiveness of O&M, but still we see very much reactive in nature. How do we act when there is a problem? And when it comes to new development, we focus mainly, when you focus on levelized cost of electricity, we only focus, still, large proportion of it focus on only CapEx. Whereas it must consider operational expenditure as well. And how robust those energy yield assessments are. Because if we prepare in theory and then it is not producing as much as expected, then there is a gap. How robust your modeling processes are. So in terms of technology, mainly solar and energy storage, whether that could be integrated with solar or just a standalone energy storage, whether in terms of floating solar or a new baby that started 3 years ago, we call it solar EV, solar power EV charging infrastructure. And different services that we offer across the whole project lifecycle from early stage concept to operational stage. When it comes to design, it's not really cost reduction that we are after. We must consider optimization of design, value engineering. And that is where this holistic view comes into picture, taking into account CapEx and OpEx. When it comes to due diligence, I spoke about in the previous session yesterday, this is probably an abundant baby in the whole project lifecycle, which play significant role to mitigate the project's lifecycle risk. It comes at a cost, but compared to the wider project cost, this is the minimum cost, which plays a significant role, whether from feasibility stage or project development, yield assessment, or construction audit stage. I'll talk about a little bit more about this PVAPM. It's a software, but it's a more of a systematic approach that we take. And that combine, what do you call it, high tech and high touch. So that the high tech element is more of those algorithms, mathematical formulas, very specific to the problem, and driven by human intelligence. I think that's where the key is. So what it does is improve overall system efficiency. And how do we do it? By doing very rigorous, detailed monitoring at a very granular level and analyze them to check health condition of those components of individual solar system. And the outcome of that help improving process for you to take going forward technical and financial decision. Here are a few case studies from different market, how much uplift that happened. On average, a project that we have done in India, about 300 megawatt of project, on average that has uplifted 10% generation. Now, I'll not go through into great details what are the reason behind it. Many of you may be aware of that, but the question is how granular we are going in those individual aspects. And I mentioned one thing, what are the reason behind this generation loss? 3 things. Lack of O&M or reactive rather than proactive O&M, not appropriate construction. We spoke about in the previous session and in this session why design is so important. If any engineer in the room, me being an engineer, you have a bigger role to play, not just designing or engineering a system. Because we see all project, they are performing, they're operating inherited design fault. Quick snapshot of the dashboard, which is very much tailor-made depending on your need. And this is what I was talking earlier. On the left-hand side, this is a selective few numbers that we have worked on average 10% uplift. And in Europe, that on average about 8% uplift happened. The difference is age of those plants. They were less than 2 years old, and the projects that we have worked on, they're about 6-7 years old. So 2 years old project is a new project. Still, look at the numbers, what we have seen. We're not expecting to see that level of deviation. If you don't do it, we end up paying more, meaning you pay double on your project life cycle. You do repowering, which is much more complex job. Again, going back to the engineers in the room, redesigning, repowering design probably 10 times more complex than a new system that you design, which comes at a much, much higher cost. We do quite a lot of on-site testing, and the few pictures that you see, including myself, bottom corner there, doing some corrosion resistivity test of a structure. But it's what I'm trying to say is a holistic approach that one needs to take when it comes to optimization performance of your solar system, whether for utility scale or for your rooftop system. Another tool that we have developed is a simplified tool to test technical and commercial viability of solar and energy storage project, particularly for commercial industrial application, to see and size of what type of load profile that you have, not just the total load profile, but also daily and nighttime pattern, so that you can design your solar system depending on the space that you have available, on whether on your roof or field adjacent to your building, and then what level of export in addition to your load profile that you are doing, and whether any size of solar system, because sizing of a battery is very essential topic to make commercially attractiveness of a project. So this tool can do a technical and commercial viability of solar, or you go with solar or energy storage system. Our global footprint, largely in Europe, and we're expanding into Southeast Asian market at the moment. We mainly work with investor funds and developer and IPPs, and quite a few partners that we work with in India. We call them partner. We never call them client or customer, because relationship management is absolutely essential. And we heard in the earlier session as well that how dynamic this world is. Not knowing the need of someone, if we say we do this way, that doesn't work. One solution doesn't actually fit to every problem. So every partner has their own requirement, and that's where we call them partner. An independent market research done by a company called GemServe, and they put us, particularly for Southeast Asian market, in the leaderboard compared to various our friends in the market in terms of our ability to produce and offer and product completeness. I'll go through very briefly some selective case studies. So this is one of the projects to demonstrate zero carbon EV charging infrastructure projects or zero carbon transportation. Very simple, just under 10 kilowatt system in the ISC campus in Bangalore. Another example, very close from here, in the British Embassy. When I was here last July, some cabinet minister came from London, so part of the G20 summit, I demonstrated those systems. So this is the picture that you see me in there. Another example from one of the largest, perhaps the largest global e-commerce company who are transiting into net zero, so commercial rooftop, and then the picture on the right you see is their solar carport system. Few case studies from utility system, so more from technical due diligence and owners engineering perspective. In the UK, 43 megawatt project. Romania, 150 plus megawatt. New Zealand, 180 plus megawatt. India, 10 megawatt in Maharashtra. PV-APM, a couple of projects in Rajasthan. This is a utility company in Switzerland, a rooftop project, uplifted up 9% after going through the full life cycle of PV-APM. Another example from UK with a 6% uplift. Landfill solar, I will finish off with this slide. We talked about waste management system. So those landfill sites are very good resource for utilizing solar, because land scarcity will not be there, because those lands are no good for any other application, but you can actually install a solar system. And grid infrastructure usually are already there, because they are producing methane gas and producing electricity, and those methane gas are actually suppressing day by day, and those land can be utilized for solar system. And we, obviously our headquarters in London, but we opened our first India office 4 months ago in India, so we have a presence in Indian market. Thank you very much, and if you have any questions, we're more than happy to answer.
Thank you, Dr. Roy, for taking us through the amazing innovations and how unique systems can enhance the solar PV's performance anywhere between 8% to upwards. Very amazing. Please be seated if you don't mind. So give him a big round of applause for Dr. Roy taking us through a beautiful analysis as well as showcasing a case study right from the down under New Zealand up to the UK, London, and a few of them in Chennai and other parts of the country. So we in IGBC also believe in solar PV is not a static device, or we should focus more on the glass and the chillers elements alone. Solar PV also needs to be chosen, maintained, operated very, very carefully. It is not like something has to be fitted and forgotten. That's the reason 2 years ago we in IGBC also started a vendor rating program also to equip whatever Dr. Roy has mentioned at a macro level on the IV test. How do you install, how do you maintain, how do you sustain the generation? And these vendors are all trained on certain elements of it. So now I open the floor to both the panelists who have taken us through, Raghu has taken through the BAS standards on various standards. As you have seen slides after slide, how do you rate, analyze, report, assess, all of that, as well as Dr. Roy on a very unique, what did you say, the high-tech as well as human intelligence-based innovative solutions, how we can enhance the generation of the solar PVs and make it more effective. The floor is open to the questions to both of us. Yeah, over to you, sir. Can I get a, Yasin, can you get a mic to him? Yasin, can I get a mic to our friend? Sir, you take it from me.
Thank you, Raghu sir and Roy sir, for the wonderful presentation. So my question is that, sir, in solar panels, the panels are getting obsolete year by year, month by month. So for example, 350 watt peak was presently the highest panel capacity 2 months back or 3 years back. Presently it is coming around 670. So what is the solution for the design optimization for that technology that has been changing continuously? So if you have some...
Such a brilliant question. You heard a terminology called bankability. 3 years ago, 350 watt peak module was a bankable product, not today. And this is the dynamics of the market that we are in. And that is why when you say design optimization, it's a moving target. So that is why if you do your design optimization well today, because you are designing a system for at least 20 years of project life cycle. Problem, I've mentioned about repowering. We are doing multiple repowering solutions. The problem is you do not get 230 watt peak module anymore. So how do you do it? You need to then not just to add cost for solar module, but you also need to cost for MMS and other components. So that doubling up your cost. So if you design your system well, those module, you choose a good product, it will last for 25 years. So I've mentioned about main 3 reasons. A is O&M, B is a construction, and is design. In the design phase, you select a component, you design it well, and it will be there for 25 years. You do not need to actually change it. But product innovation, technology innovation is going to come. So 600 plus watt peak module is a very common product. And the way that is market is moving, for example, 350 watt peak module, they are like polysilicon module. It doesn't exist. Even cell production is not happening of polysilicon. What has happened during COVID period? Now this is an interesting point. There is a huge gap in between deployment and innovation. During COVID period, deployment was close to 0, but significant innovation happened in module technology. So we transformed from polysilicon to monopark, which was around 450 or 550 watt peak module, and now we are talking about TOPCon solar cell. And there we are talking about 600 plus watt peak.